Welcome. In the next few sessions, we will look at examples of method of substitution for integration. Substitution is one of the most powerful methods of integration. It's also somewhat complicated. The substitution to use may not immediately be obvious. The best way to develop intuition about what substitution to use and if it will work is to do a lot of examples. Even though there are no hard and fast rule, there are some rules of thumb. Since we want to reduce the problem to something we already know, and there are basically just three integrals we know: the power rule, 1 over x, and exponentials, where the exponent is a number times the variable. It's just a matter of trying to see if we have that particular pattern in our integral. So if you have power of some expression, especially a polynomial, you try setting that polynomial to be u. If you have an exponential function, you try setting the exponent to be u. If you have a fraction in which the denominator is a polynomial, you try setting the denominator to be u. There are few exceptions to this, which I will point out as we do our examples. Our first example is the integral of x power 4 plus 2x squared plus 5 to the power 8 times x cubed plus x dx. So rule of thumb suggests that we set u equal to x power 4 plus 2x squared plus 5. Derivative of u with respect to x is 4x cubed plus 4x. So du is 4x cubed plus 4x dx. What I have is x cubed plus x dx. These differ by the constant factor of 4 because I can factor 4 out of du, and the other factor is x cubed plus x dx, which is what I have in the integral. So the first factor in the integrand, x power 4 plus 2x squared plus 5 to the power 8 is just u power 8, and x cubed plus x dx is du over 4. So I have 1/4 u power 8 du, which I can integrate using the power rule. 1/4 is a constant factor, I keep it as it is, and antiderivative for u power 8 is u power 9 over 9, and I have plus the constant of integration. Now go back to the original variable x, substitute x power 4 plus 2x squared plus 5 for u, and that gives us the answer. X power 4 plus 2x squared plus 5 to the power 9 over 36 plus c. There's a slightly different way to work substitution. I will stick with the way the book does it, which is the way we did our last two examples. The alternate method is to simply solve for dx in terms of du and x, put it back in the integrand, and then try to simplify. This is a little bit trickier, but some people like it. We'll just do that once. So I'm going to illustrate this method using the integral of e to the x squared plus 1 x dx. Following our rule of thumb, we will set u to be the exponent x squared plus 1. Then du will be 2x dx. I solve for dx from this. Dx is du over 2x. Then you substitute this in the integral for dx. Write as much as possible in terms of u. The exponent on e is x squared plus 1. That's u, so I write that as e to the u. I have x, and then I have dx. And dx is du over 2x. Now I simplify this. So note that now all the x's are gone. I have only u's and du left. So I can do this integral. I have 1/2 times e to the u du. So I have 1/2 e to the u plus c as the general antiderivative. Now I go back to the original variable. Substitute x squared plus 1 for u. So I get 1/2 e to the x squared plus 1 plus c as our final answer.